In our last video, we discussed about unlike and like terms, and in this video tutorial, we are going to solve some problems related to that topic. Those of you who haven't watched that portion, the theoretical portion on unlike and like terms, for them I'll put the video link in the description box below. So first watch that video so that you can understand here. Now we have this algebraic expression 5x cubed minus 2x squared plus 4x minus 6. We can write this as 5x cubed within the bracket plus within the bracket minus 2x squared plus 4x plus within the bracket minus 6. Now we have four terms here. This is the first term, this is the second term, this is the third term, and this is the fourth term. So we have total number of four terms here. First, tell whether we have any like terms or not. So if you remember, we have discussed this, that whenever you are you have to tell whether there are like terms or not. What we do is we simply ignore these coefficients. We simply ignore these coefficients or numerical factors of that terms. So like in this term, the coefficient is what? 5, or its numerical factor is 5. In this one, the coefficient is minus 2, here 4, and here minus 6. So simply ignore it and start comparing the variables. This is x cubed. So are this x cubed and minus 2x squared, are these like terms? You will say that, you know what, this is actually minus 5x cubed, and this is 5x cubed, and this is minus 2x squared. They contain x and x. No, this is x cubed and this is x squared. We said that whenever you are even comparing the variables, compare that whether they have the same number of variables or not, because this x cubed can be written as x times x times x. That is, these have three algebraic factors, one, second one, and the third one, right? In this one, even if we ignore this minus 2 and 5, this is x squared. So if you are thinking that here also we have x, here also we have x, but as I told you, here you have 3x and here you have only 2x, because x can be written as x squared can be written as x times x. It means that if you are checking the variable in this term minus 2x squared, we have actually two algebraic factors, and those that are x and x. Okay, so clearly even this cannot match. So what about this 4x? So some of you would say that, hey, you know what, this is x, so let's compare it. Again, same thing. Here you have only one algebraic factor, that is x. So here you have 3, here you have 2, here you have only 1. Even if you are comparing the variables, the number of variables should be same, because that tells that the number of algebraic factors are actually same. This is minus 6. Clearly minus 6 cannot have any variable, right? And therefore it will not contain any algebraic factors. So clearly in this one, none of the terms are actually like terms. There are no like terms, because none of the terms have same variable, right, or the same algebraic factors. So all are unlike terms. Okay, in this one, this is minus 10xyz, then minus 5xyxz, minus 7zyx, plus 4yzx, plus 6zxy, minus 2xyxzy, plus 5. Now, if you look at, let's write it in this way. Within the bracket minus 10xyz, plus within the bracket minus 5yxz, plus within the bracket minus 7zyx, plus 4yzx, plus 6zxy, plus within the bracket minus 2xzy, and plus 5. Now we have 1, 2, 3, 4, 5, 6 and 7 terms. So this is term number 1, this is term number 2, this is term number 3, this is term number 4, this is 5, this is 6 and this is 7. Now first let's check for like terms. Now for like terms, you take those terms. Like terms are those terms which have exactly the same number of variables or the same variables. In this term 1, this has 3 variables x, y, z. So x, y and z. Clearly these are the 3 algebraic factors of this term x, y, z. In this one we have again y, x and z. Now clearly, as we said, you simply ignore the numerical coefficient. We simply ignore the coefficient of all the terms when we are comparing whether the terms are like or not. So in this one we have again, in this term we have 3 algebraic factors, and those are y, x and z. Exactly the same to this one. The only thing is that their orders are different. In this case we have x, y, z, but in this case we have y, x, z. Orders don't matter. Why? Because if you write this in the form of its factors, then clearly it can be written as minus 10 times x times y times z, right? So these are the 3 algebraic factors. What are the 3 algebraic factors? X, y and z. This one can be written as minus 5 times y times x times z. Clearly ignore this numerical factor, and it has 3 algebraic factors, y, x and z, exactly the same to this one, right? So orders don't matter. What matters is whether you have exactly the same number of variables or not. What about this one? This is minus 7 zyx. Again, what are the 3 algebraic factors? The 3 algebraic factors are actually z, y and x. Only orders are different, rest all the variables are same. X, y, z, y, x, z, z, y, x. These 3 are like terms. What about this one? Even in this one you have again exactly the 3 same variables as the previous one. Y, z and x. The only difference is that again the orders of these variables are different, right? So x, y, z, y, x, z, z, y, x, y, z, x. These 4 terms are actually like terms. What about this one? You will say that's really very easy. Again, it has z, x and y as the algebraic factors or the exact variables, again z, x, y. So 1, 2, 3, 4, 5, these all are like terms. What about this one? Even in this case the algebraic factors are x, z and y, right? So only thing is the orders are different. 1, 2, 3, 4, 5, 6. These all are actually like terms. And this is 5. So the 5 one, this is the constant. This is the constant. And it will not contain any variable. That is, it will not have any algebraic factors, right? So clearly these are the like terms, but this one is unlike term. Like this is not like to any of these terms. It's completely different. And as we have discussed in the theoretical portion, that when you have like terms, you can actually, add all the like terms together. So here 1, 2, 3, 4, 5, 6 like terms all have x, y, z as their numerical algebraic factors. So what you have to do is simply write, if you want to add them, simply write what? X, y and z. Simply write what? X, y, z. We don't have to think of orders. What matters is that whether they are like or not. If they are like, so simply write the algebraic factors. So x, y, z, and here we have minus 10, then we have plus within the bracket minus 5, plus within the bracket minus 7, plus 4, plus 6, plus within the bracket minus 2. If you solve it, this is minus 10, minus 5 is minus 15, minus 22, minus 18 minus 12 and minus 14. So this is minus 14 xyz plus 5. That is, if you simplify this algebraic expression, you'll get this one, right? So if some of you are thinking that can we write it like this, minus 14 yxz plus 5? Yes, exactly, you can write it. So some of you think that then we can write it as minus 14 zxy plus 5. Is this correct? Yes, exactly, this is again correct. I'm again repeating, what matters is the same algebraic factors, right? Doesn't matter in what order you put up, the thing is that you add up all the like terms together, right? So you simply add all the numerical coefficients and you write the factors together. Doesn't matter what are their orders. In this one, we have this algebraic expression 4p squared q 6qp squared plus 8q squared p minus 7p squared minus 5. Let's write it as 4p squared q plus 6qp squared plus 8q squared p plus within the bracket minus 7pq squared and minus 5. Now we have how many terms? We have one term, we have two term, we have third term, we have fourth term, and we have fifth term. Sorry, even we can put this in the bracket. Plus minus 5. And we have this fifth term. Now let's first talk about like terms. Are there any like terms or not? In this term 1, you have, if you write this in the form of factors, right? Only we are focusing on the algebraic factors. Ignore this numerical coefficients in all of these terms. So this is p squared q, and you can write it as p times q, because this is p squared, right? So what are the three algebraic factors that are p, p and q, right? P, p and q. Okay, what about this one? In this we have q p squared. This can be written as q times p times p. So again you have p, p and q as the factors. The only difference was that here we have p squared q and here we have qp squared. Only the order has been changed, right? But if you check, it has the exactly same variables and the same number of variables. There are two variables only, p and q, but it has a p squared q and it also has qp squared. So p squared here also, p squared here also. Here also you have q, here also we have q. In this one, this is 8q squared p. So this is q squared p. These two are like terms, right? First term and this one, these two are like terms. 4p squared q and 6qp squared. In this one you have q squared p. This can be written as q times p. So the three algebraic factors are what? Q, q and p, right? Q, q and p. Now this is not exactly the same as these two terms. Yes, they have only two terms, that is q and p, but if you look here, then it has actually two q's and only one p, right? So it's different from this one. So 8q squared p is unlike to this one and is unlike to this one. These are not like terms. What about this one? In this case we have pq squared. Again you have two q's, right? Q and one p. Exactly the same to this one. So this term and this one, these two terms are like terms. These two terms are like terms, but if you compare this one and this one, unlike. If you compare this one and this one, unlike, and same for this. Now this is minus 5, a constant. A constant cannot have any variables, so clearly this will be unlike to all of these terms, right? This will be. Now just simply add up the like terms together. If you add up the like terms together, if you add it up, so these are two like terms, you can write it as p squared q, or even you can write qp squared. There will be no difference. If you add 4 plus 6, you get 10. You get 10. The only thing is you can write it in any order. Then plus 8 minus 7 will be what? 1. So you can write it as, we don't need to write 1, so ignore it. Q squared p, right? Or even you can write it as pq squared. Again, order doesn't matter. Plus, here we have minus 5. So if you plus minus 5 and plus minus 5, this can be written as 10p squared q plus q squared p. Again, whenever you have 1 as a coefficient, ignore it, and this becomes minus 5, and this becomes 10qp squared plus pq squared minus 5. These two are exactly the same algebraic expression. The only thing is that we have shown that you can write it in any different order. In this case, you have minus 8pqrs minus 5qrps and plus 5sqrp. Let's check for like terms. Again, ignore the coefficients. Ignore this, and ignore this. If you want to write it in the form of, like, within the bracket minus 8 pqrs plus in the bracket minus 5 qrps plus 5sqrp, right? So we said that ignore this, and ignore this. Now match the algebraic factors of these terms. This is pqrs. So we have p, q, r and s as algebraic factors of the term 1. Here also you have q, r, p, s. So you can check that only order is different, right? Rest, the number of variables and the variables are exactly the same. Same thing is here, s, q, r, p. You have exactly the 4 factors p, q, r, s, and that is exactly the same to this term and to this term. All these 3 terms are like terms, right? So all these 3 terms are like terms. And if you want to write it like this, p, q, r, s, and add this. So minus 8, minus 5, and plus 5. You'll get minus 8 p, q, r, s. You can simplify this one as this algebraic expression, right? So this is the importance of like and unlike terms. You can add up like terms, and you cannot add up unlike terms.